So let's start with one of these types. This one, we're going to start with primitive types. Oops, wrong buttons. 1 second. I got to press on the draw. There we go. So we're going to start with these things we call primitive types. Primitive types. And the first primitive type is we're going to talk about numbers, right? So what kind of numbers we have. So this number that we're interested is integer types. Integer types means they're whole numbers. So they could be any number such as minus 12, minus 2. It could be also 0. It could be positive numbers 2, 5. Integer means whole numbers. Doesn't matter if they're negative, it doesn't matter if they're positive, but they have to be whole numbers. They can't be partial numbers. They cannot be, let's say, 2.34. This is wrong. It's not possible to put it in there. Okay? Now, inside of these whole numbers, there's a few different variable types that exist. So let's go through them. Sorry, my cat is trying to climb on me. So what different types of numbers, or what type of, sorry, I'm getting confused with my cat. What different types of primitive integers there exist? There's a few of them, and they're interesting, and again, they're good to know. So we got something called long, we got something called integer, int, short, and byte. Okay? It goes from biggest, let me change color, biggest to smallest. Okay, so again, remember the amount of bits that we've utilized before? You got to remember that, well, you got to know, if you don't know, that every 1 byte, it equals to 8 bits. Okay? So let me change it from red. It's a bit weird. So what does that mean is, well, 1 byte here, that's the smallest integer type that I have inside Java as a primitive type, is 1 byte. Let's say, let's write here bytes. This one is 1. And the amount of bits that it equals to, let me change some colors here. So the amount of bits it equals to is 8, right? 1 byte equals 8 bits, right? We can't always use bits because it becomes really big numbers, but I'm going to try and give you these ones while we're doing it. So in the case of short, it's kind of double of it, so we do 2. Int is again double of it, 4. Again, long is double of it, the previous one, so we're at 8. Right? And when we come down to bits, we do the same thing again. So 16, double it again, we're at 32, double it again, we're at 64 bits. So now this is important, especially if you want to go into a company. Knowing the size kind of matters. Not always, but kind of matters. Give you a better example, you guys are becoming mobile developers. And not all phones are the top of the line phones. Not everyone could go ahead and buy $500 to $1,000 phone. Some people, they only buy a $60 phone or a $100 phone. Sorry, my cat is playing with my stuff. So with that limitation, okay, sorry. With that limitation, we gotta be a bit more conscious about what variables we create. So the amount of space that we utilize, right? So this is something called space sorry, my cat really distracted me. This is something called space complexity. Oh my god, I'm having a blank now. It doesn't matter. The point is, we need to figure out what's the size we're utilizing on that user's phone to not go overboard. So sometimes you know that you just need a bit of space. Well, then you're going to start using something smaller. This is really important because we want to decrease the amount of size our application takes on the user's phone. A great example would be if your phone is maxed out, if you don't have any more space on your phone, what are you going to delete first? Are you going to delete those priceless pictures? No, those pictures are, you remember, it's your family, your friends. Are you going to delete the text messages? No, again, you want to kind of keep memory of that. What you're going to go and delete is to go check which application uses too much space, and you're just going to go and delete it. So this is why, let's say Facebook or any other application like Instagram and so forth, so on, they will try to take a few megabytes at max. And that's basically just the code and nothing else, right? We want to leave our footprints as least amount as possible. Now, there is some stuff we need to note. So let's go ahead and create some variables here. So this, we could leave it there. Or, yeah, we actually, you know what? Let me go create a new one. So let's say basics, and we're going to say integer variables. Okay. So let's go ahead and create a few of these variables, just so you know how to create them. So we got bytes, byte, I don't know, let's say smallest. Okay, give some good variable names. I'm just creating stuff just to show you, so their variable names are really bad. I'm gonna initialize it to, let's say, some value, 0, doesn't really matter. We got also short, which is double the size of smallest, so smaller, I don't know, small, let's say. I'm just gonna give it, let's say, a value of 1. It doesn't really matter the value here. It does matter because, it does matter because remember, we're limited in bits. So after 8 bits, what can we have in there? I think we did the 8 bits and we were reaching 255. So if I go to 55, 1 second, sorry, I did a mistake, cast to byte. So it just needs to, why am I getting a problem here? Well, okay, so maximum size is 1 byte. This should have been fine. But anyway, we're just doing a quick cast. I'm not familiar with Java that much, but let's keep going. Then we also have integers. Let's say this is big. This is a 32-bit size. So it contains 4 bytes. Now we could go bigger numbers. I don't remember the maximum size. You could actually do this thing called a constant by doing math, I think, dot maximum. Nope. Integer, there we go. Max value. So this is a constant. We'll come back to it, but it contains the maximum integer you could have. For now, we could just put our mouse over it to see what it is. It's 2 to the power of 31 minus 1, which is also equal to this number here. It's my little quick trick. There we go. If I go 1 digit higher than this, well, then my integer cannot contain that value. So if I go 8, you'll notice I get an error. Integer number is too large. Okay, so this is interesting ways of figuring things out. And lastly, we got our long. So we're going to type in long, biggest. And here we're going to, again, type in the longest number. Well, any number we type in. It's a good convention to put a capital letter L at the end of it and then a semicolon. The L is to kind of notify the compiler that this number on the right side, is a long character and not an integer. By default, it's always integer. And you could see here I got a problem because it was requesting bytes and I give it an integer and it needed to be cast. We'll talk about this another time. Okay, so by convention, you should add L. Mind you, in our exercises and for this whole class, integers should be enough for you. Okay? So let's go check out this long number, and we're gonna start cleaning it up, and the clean part is important. So we could again do this shortcut, max, no, sorry, just trying to see what's the biggest max value. And again, I'm gonna just put my mouse over it. Then this number is huge. All right. Now, one problem we get with integers or really big numbers, it's hard to read. So you see that in the case of our integer and the case of our long. So one thing that we could do now inside Java, and in most languages, pretty much every language, is you could add underscore. The underscore is ignored. The underscore is just there for it to be more legible for the user. Sorry, for the programmer, not for the user. So you could see here that our maximum number is at 2,147,483,647. Much easier to read than if it was without these underscores. And again, the underscore, you could put it wherever you want. I put it at every 3 numbers. It's up to you. Cool. And as always, all of these numbers could be printed out. Oops. Why is my thing not coming out? Ooh, I forgot to do something. I'm so blind. Sorry, I wasn't thinking. Remember, we got to create our main method. That's why nothing was working correctly. And we could now do system.out. And we could say smallest. We could do system.out, and let's say we print our biggest. Notice that smallest and biggest are white, while big and small are gray. This is because I'm not using those variables anywhere. Let's run this, and we could clear my drawings. And you could see the values being shown here. Cool. Thank you guys. I'll see you in the next variable.